Hello everyone. This is Team The Minions, and this is our presentation of our capstone project, Brain Tumor Classification System. And this is our agenda, and we'll go through each section one by one by our team members. And here are our team members. Vaishnavi and Christiana, Deepika, Grishma will be responsible for machine learning part. And Yutong and Lingy will be responsible for the backend part. And Yash and Ramiz, Ramiz, am I pronouncing your name right?
Yeah.
Okay.
Yeah,
And will
you're
be
correct.
responsible for the front end. Yeah, here we go with our problem statement.
Yeah, so coming to problem statement, so many healthcare facilities struggle with diagnosing pneumonia and brain tumor effectively due to limited specialists and the use of separate systems for different diseases. These challenges led to delays in diagnosis, longer patient wait times, and increased pressure on healthcare professionals. So currently, the radiologists manually analyze medical image. It's a time-consuming and labor-intensive process. So, with hundreds of images to review daily, delays are inevitable, especially in hospitals with limited staff. This inefficiency makes it difficult to provide timely and accurate diagnosis. So, to solve this problem, we propose ImageMedix, an AI-powered system that automates medical image classification for lung X-rays and brain MRIs. By using deep learning models, our system can provide a preliminary diagnosis, assisting healthcare professionals in making faster and more informed decisions. This solution aims to improve diagnostic efficiency, reduce delays, and enhance patient care.
The project description, the name of our project is ImageMedix. It's a tool that helps doctors and healthcare professionals to detect pneumonia and brain tumors quickly and accurately. It works by analyzing lung x-rays to detect pneumonia and brain MRI scans to detect brain tumors. System automatically identifies whether the image is an X-ray or MRI, then checks the signs for the disease. Unlike the other tools, separate diagnostic systems that handle only one type of image, our application streamlines diagnosis by analyzing both image types within a single system. That could save doctors and professionals time and improving diagnostic accuracy. And coming for the benefit outcomes, it could be faster diagnosis, improved accuracy, and resource optimization that saves doctors times, reduce mistakes manually, and helps hospitals with fewer specialists make better decisions. And that will be our project GitHub link for updates and further development. You can check it out through that link.
And here it goes with our key personas that represent our primary users and their unique needs. So the first one persona is Dr. James. He's a 45-year-old senior radiologist at Metropolitan Hospital and with over 20 years of experience. So he represents our expert level users, who's handling large volumes of diagnostic imaging daily and facing challenges with workload management and time constraints. And he needs efficient tools to maintain high diagnostic accuracy. So for Dr. Pato's main pain point is being overloaded with image analysis and administrative duties, so which our system addresses by automating initial classification. And next we have Dr. Susan. So she's a 38-year-old general practitioner working in a clinic. She represents our users in resource-limited settings who's working without immediate access to specialists, right? And need reliable diagnostic support tools and handling diverse medical cases independently. So our system particularly benefits Dr. Chen by providing reliable preliminary diagnosis and enabling faster decision-making in areas with limited specialist access. And so this is our third personas. Dr. Raj, a 50-year-old healthcare director of a large hospital. So he represents our administrative users. he is focusing on improving overall healthcare efficiency and dealing with resource allocation challenges. And so he needs solutions that works across multiple facilities. Yeah, so this person is highlight the diverse needs our system must address from improving efficiency in high volume settings to providing crucial support in resource limited areas. So by understanding these user profiles, we can better tailor our solutions to meet real healthcare needs. And here's go with our technologies part.
Yeah, the technology here we use for front-end React.js, it uses to create a user-friendly interface that allows healthcare professionals to upload and view medical images easily. And for backend, we use Node.js, Flask, and MongoDB. For Node.js, it handles API requests and manages communication between the front-end and backend services. And for the Flask, it supports modern interface by running machine learning models for image classification and diagnosis. And for MongoDB, it stores user data, images, and diagnostic results, enabling secure and scalable data management. And for machine learning, it built using PyTorch and trained on datasets for lung X-rays and brain MRIs. And for cloud infrastructure, it uses for Deloitte using AWS. And next slide. And for the algorithms, the systems user to core algorithm based on pre-trained deep learning models. ResNet model find turned on a data set of medical images, and it uses to classify whether the upload image is lung X-ray or brain MRI. It depending on classification result that system proceeds to second stage. For the lung X-rays, a fine-tuned efficient net model detects and classifies pneumonia into normal, viral, or bacterial categories by analyzing lung patterns. For brain MRIs, the same efficient net model is used to detect the classified brain tumors into glioma and pneumonia, or no tumor by identifying abnormalities in brain structures. These models provide high accuracy and efficiency, enabling reliable diagnosis for both images.
As a sprint zero, we will start the project initiation. Mainly we focus on idea development, project planning, and setting up initial deliverables, including a presentation and a wiki update. As a sprint one, we will start with core development in design and implementation, including front-end, back-end, and machine learning model integration. As a deliverable, we will present the presentation and we will update the wiki page. For sprint two, we will start advanced development, we focus on refining model performance, system integration, and we will add additional features. As a deliverable, we will present presentations, we will prepare for technical paper, and we'll update the wiki page also. As a sprint three, this is our final testing and optimization. So we conduct system testing, performance improvement, and final documentation updates. As a deliverable, we will focus on presentation and we will update the technical paper and wiki page same as. So next slide will Deepika explain.
Yeah, I'm telling about the team working agreement. Like coming to the responsible, everyone have to complete their task in the time and maintain the quality of work so that there are no clashes or it works smoothly. And everyone, like if there are any meetings scheduled or any project is anything is going in the project, everyone has to work. If they are not able to work, if they block anything, then it can cause delay in the project, and there should be a communication between the group members so that like we can use any of the platforms like WhatsApp, Discord, or any Google Meet or Zoom or anything so that we could discuss our topic daily, what's going on. And there should be a weekly meetings, as we have already discussed that they're gonna be a weekly stand up, like we put it on Thursday so that we could everyone discussing that what's happening and what's going on the individual work. And meeting attendance, like everyone should attend the meeting once it has schedule. And if we are allocated to any task, so that everyone has to complete the task by that time so that there won't be any pending works, so that we could submit in the week. And also and if someone is absent in an emergency, so they should inform to the team, and they like when they come back, they should have the call with somebody and know all the work what has happened, and they should be up to date. And collaboration, coming to collaboration, and everybody have to assign to their work and have to fulfill their role, so that there won't be any what pending works, as I already told. And if somebody has stuck somewhere, everyone can help each other. There shouldn't be any eager what uh, any issues or selfishness in between the team. If someone has, it will be stopped in the middle. If somebody know more, they can help each other. And coming to deliverables, and we also have if like that's what we can give them feedback. Deliverables, for every sprint we have some documentation presentations will be there, so we have to be on up to date. And everyone if some work is done, there should be a peer-to-peer communication, so that everybody can know what's happening in the project and the deliverables. Each sprint will include presentation, yeah, that's happened. Work will be reviewed, code and documentation. And when we write a code, it should be simplified so that everybody can understand, and the functionality should be known to everyone, so that they can understand easily. So it should be like user friendly. Documentation will be updated regularly by the respective team members. Yeah, that we know. Decision making, when the decision is made, it should be made in the group, like when we had a meeting, so that everybody can know. Like if it is done between some amount of people, then others will be lagged. So when we make a meeting, so that everyone can tell their issues or anything, so that we can solve it. In case of any disagreements, like whoever, whatever the voting results, by that voting results, we can take the final decision. Conflicts, if we have any arguments or anything, we can tell it in the meetings, so that everyone can know and everyone can solve it by giving their ideas. If it is not resolved, then we can take it to the further. Yeah, that's thing. And next slide will be explained by Vaishnavi.
Hello, everybody. So, what went well and areas for improvement? Coming to what went well, first and foremost, everyone shared their ideas on time, which kept us aligned and ensured that we had a strong foundation to build upon. And secondly, our role assignments went smoothly. Everyone know their responsibilities, which helped us stay organized and productive. The clarity made this easier for us to focus on our task without unnecessary confusions. And another positive thing was our strong communication. We kept each other updated, shared relevant insights, and ensured that no one was left out of the loop. And lastly, we respected each other's idea. So that's the thing. And the things that can be improved is more discussion and collaboration in the future will allow us to refine our ideas further. The more we communicate, the better actions we can develop. And we should set up our regular meetings, and also we have decided on Thursday at 7 p.m. as our fixed time. So this will provide consistency and keep our workflow structured. And lastly, we can improve by discussing more about development and task allocation. So ensuring this will improve a well-planned project. And action items for the moving forward is stick to the deadlines and plan ahead. So meeting the deadlines ensures steady progress and avoid the late minute rushes. And to be very clear and specific about the task, everyone should have a well defined understanding of what needs to be done, and break down task into smaller steps. This makes the workload manageable and improves productivity. And also working on user interface and deep learning components. By implementing these steps, we can ensure a smoother workflow and better results. And next is the Wikipedia link for the project, and that's it. Thank you.
Thank you. So this is Team The Minions, and thank you so much.